Now the last one in the chapter of nitric acid is, we will go for the test of nitrates or the test of nitric acid. We will go for. Now the test of nitric acid, we have already seen it, that when nitric acid is being heated, it gives reddish brown colored gas, which is nitrogen dioxide. We have seen this particular one, that HNO3, when you are heating it, it is unstable also. You have read, I have told you that HNO3, even if you keep it at room temperature in a plain bottle, you will find it out that it gives nitrogen dioxide gas, due to which nitric acid is having what is that, slight yellowish tinge it is having due to the decomposition of nitric acid to nitrogen dioxide. So you have studied this particular one. So here nitric acid, if you take it, it will decompose to give you nothing but nitrogen dioxide plus water plus oxygen. You can balance it this one. This nitrogen dioxide is a reddish brown colored gas. So simply if you heat nitric acid, it will give you a reddish brown colored gas, which is nitrogen dioxide, which is also having a pungent smelling gas also, we can say that. But the most important is that it gives a reddish brown colored fumes. Fine. Next is, if you that is take copper, if you have taken it, this reaction you have also studied in the chapter, that copper, when you are reacting with nitric acid, then what it gives you? It gives you nothing but copper nitrate plus water plus nitrogen dioxide gas is being evolved. You have studied this particular thing because copper is being oxidized here. Got it? So nitric acid here acts as an oxidizing agent. You have studied. But the most importantly, you are getting that is nothing but copper nitrate, which is blue in color, and the nitrogen dioxide gas is evolved, which is nothing but reddish brown color. If you complete this equation, CuNO3 whole twice plus water plus NO2, you get it. So in this way, you will see that nitrogen dioxide gas is being evolved. We can see. Clear? So we have seen all these reactions. Now next is one of the very important, what you can say, reactions or the test, I should say, very important, this particular one, which is known as brown ring test. You will be doing it in the lab also, this particular test. Brown ring test. This test is known as brown ring test. Very important test. Very important. In class 11 and 12, it is a confirmatory test for nitrates. If a compound nitrate is given, how do we come to know? By the help of brown ring test. Now listen carefully what I am saying you. Alright, I'll try to explain you as clear as possible. I'll try to explain it to you. Now this is a test tube, you will be taking it. And you will be taking either nitric acid or nitrates. You will be taking it initially. Listen very carefully. Nitric acid or nitrates, I have taken it here. Got it? Nitric acid or nitrates here, I have taken it. Now, initially, anything, either potassium nitrate, ammonium nitrate, calcium nitrate, any nitrate or nitric acid, I will take it here. Fine. Now, after that, what I will do is that I will be adding FeSO4, freshly prepared ferrous sulfate. I will be adding it. What I said, freshly prepared ferrous sulfate, I will be adding to it. Now, the question is, why freshly prepared? Because if you take ferrous sulfate, the stored one, which is being stored in the lab, then ferrous sulfate easily gets oxidized to ferric sulfate. FeSO4 gets oxidized to Fe2SO4 whole thrice. It gets easily oxidized. And ferric sulfate does not give the brown ring test. You will come to know why. The reason you will see, because the reaction when I write it down, then you will come to know. So ferrous sulfate only gives a brown ring test. The ferric sulfate does not give the brown ring test. So hence, we are not going to use the stored ferrous sulfate. We are going to use a freshly prepared ferrous sulfate. We are going to use it. So I am going to add it, the freshly prepared ferrous sulfate from here. So you can see the blue color, I am drawing it here. The freshly prepared ferrous sulfate, I am going to add it here. Alright, I am going to add it. Freshly prepared, remember it, I told you the reason. Now, from this particular side, slowly, from this side, slowly, you will add concentrated sulfuric acid in the test tube. Why slowly? Because when concentrated sulfuric acid reacts with ferrous, all these are solution. Water is there. When concentrated sulfuric acid comes in contact with water, it's an what you can say, exothermic reactions. So slowly, if you add it, then what will happen is that heat will be evolved, but that heat will be slowly absorbed by this particular solution slowly. And if you add suddenly, then large amount of heat will be evolved, and by that the brown ring will not be formed. The test you will not be getting it. Alright, test you will not be getting it. So hence, for that particular purpose, slowly you need to add concentrated sulfuric acid from the side of the test tube. Understood why slowly? Because if you add it faster, means concentrated sulfuric acid, when it reacts with water, because water is here in our solution, so it will evolve out a large amount of heat, and hence this brown ring will never be formed in this particular case. I'll tell you the reason. So hence you need to add slowly. When you will add slowly, after adding slowly, what you do is that you don't disturb this particular test tube. You just take the, what you can say, the test tube holder, and you put it in ice cold water. a beaker containing ice cold water, or you show this walls of the test tube, the outer walls of the test tube, not the inner one, because what will come inside there. The outer walls of the test tube will show it under running tap water. Why? To cool down, because I said no, exothermic reaction is going to take place. So cool down, you just what you can say, show it under running tap water. But best in the lab, what we do is that we advise the children that you take the test tube and you put it in that is ice cold water. You put it in ice cold water, this particular one. When you are putting in ice cold water the test tube containing all these mixtures, here you will be seeing a ring is being formed here at the junction of ferrous sulfate and what you can say, at the junction of sulfuric acid and this ferrous sulfate, a ring will be formed here, a brown colored ring will be formed here, because sulfuric acid will be adding it from this particular side, sulfuric acid slowly will be adding it, so that the junction of this you will be getting a ring will be formed. Which ring? A brown colored ring. But this ring is temporary in nature. Why it is temporary? Because if we shake this particular ring, what will happen? Again same thing, concentrated sulfuric acid will evolve the heat, and this heat will decompose the brown ring. Because brown ring, how it is being formed? What I said you? FeSO4 when reacts with nitric oxide. Where from you get nitric oxide? When nitrate or nitric acid when reacts with ferrous sulfate, it evolves NO gas. Got it? This NO reacts with FeSO4 further to form FeSO4.NO, which is nothing but known as brown ring, and the name of the compound is nitrosoferrous sulfate. Nitrosoferrous sulfate. Now the compound is brown ring. It's nitrosoferrous sulfate which is being formed. Understood what I said? How the brown ring is being formed. Got it? When you are adding nitric acid or nitrate with ferrous sulfate, when it will react, then it is going to form what is nothing but FeSO, what you can say, NO gas is evolved. This NO further reacts with FeSO4 to form FeSO4.NO. That is, a brown ring will be formed. So when you are shaking the test tube, alright, you should keep it undisturbed. I said you in the beginning itself. If you are shaking the test tube, then concentrated sulfuric acid will again dissolve in water and will evolve of the heat. And this heat will dissociate this particular bond, because this is a weak bond. Dot means what? It's a weak bond. It's a weak bond between ferrous sulfate and nitric oxide, we can say that. So that bond will break, and hence the brown ring will disappear. Got it? So for that particular purpose, you need to what you can say, keep it for some time. Of course, it is going to disappear after some time only. Why? Because this dissolves in it. This brown ring, it ultimately dissolves in it, because ultimately the reaction is going taking place now. Ultimately, if you don't shake it also, then still the reaction is taking place inside it. That also liberates the heat, but that will liberate the heat slowly. But if you shake it, means the heat will be liberated faster. The reason is that ultimately you don't think the brown ring will last forever. It will remain forever without what you can say, shaking it. No, heat is liberated in either of the cases. If you shake it, the heat will be liberated faster and the brown will disappear immediately. But if you don't shake it, heat is liberated, but that is very, very slowly the heat is liberated, and ultimately the brown ring dissolves in it, because it breaks up, the bond breaks up. Alright, so hence you need to take here freshly prepared ferrous sulfate, because ferric sulfate does not give this test, as you have seen it here. Ferrous sulfate gives a test. Then you need to add concentrated sulfuric acid slowly, because if you are adding it faster, then what will happen is that exothermic reaction is going to take place. And you may also, sometimes what it happens is that in the lab we have seen it, the children, those who do not listen to us, alright, they don't listen to the teacher and they add it faster, then what happens is that this sulfuric acid comes out, alright, with a huge pressure it comes out, and it may stick, it may strike to your face or to your clothes and all these things, and you may suffer any accident also in that particular case. So you need to do it properly, you need to listen to your teacher and have this particular precautions. And when you are putting it in a what you can say, the under tap water, when you are showing it, or when you are putting it in a ice cold mixture, then you need to see that you are not disturbing it. Then the brown ring will not be formed, because I said you that while disturbing, what is going to happen? The heat will be liberated. Alright, due to concentrated sulfuric acid, when dissolves in water, the heat is going to liberate it, and that heat will break this bond, and due to which the brown ring is going to disappear. Alright, so this is a very sensitive test, but you need to do it. You need to learn this particular thing. Alright, in the lab you will be doing it and you will be learning it, this thing. This is called as a test for nitrates, we can say that, or nitric acid, the brown ring test, a very famous test. Now next is, when we will be heating the nitrates, then what is going to happen? See, we will be now I am coming to the uses of nitric acid. I have finished the what you can say, the Brown ring test. Now we'll come to the uses of nitric acid. Now before going to the nitrates, let me tell you some other uses. You can see that nitric acid is being used for the preparation of fertilizers like calcium nitrate, ammonium nitrate and all those things. It is being used to prepare TNT, trinitrotoluene. It is used to prepare trinitroglycerin. It is used to prepare trinitrocellulose, which can be used for the what you can say preparation of what to say that trinitrocellulose. It can be used to prepare, I'm forgetting that, explosives. Alright, it can also be used for the preparation of fibers or fabrics, we can say that. It is also used for etching purposes, for the cleaning of the glass and for cleaning of the metals. It is used to prepare aqua regia, we can say that. So many uses are there. Please go through the uses which is there in your book, we can say that. Clear? Now I am telling one more thing to you about nitrates. Alright, now if you take, listen carefully, if you take potassium nitrate and sodium nitrate, it will decompose to give you nothing but nitrite and oxygen gas. Look here, that is sodium and potassium nitrate, KNO3 or NNO3 on heating will give you KNO2 plus O2. Alright, clear? Now, after that, calcium to copper, any nitrate if you are taking, from calcium to copper. Alright, calcium to copper, remember it, what are the elements are there? The metal activity series. Alright, calcium is there, magnesium is there, aluminium is there, zinc is there, iron is there, lead is there, nickel is there, tin is there, copper is there. Got it? So calcium to copper, any nitrate if you are taking it and you are heating it, then what I am going to get it? Oxide, nitrogen dioxide and oxygen. Please balance it by yourself. Now if I take, that is mercury and silver nitrate, got it? Mercury nitrate or silver nitrate, like HgNO3 whole twice, if I am taking it, it will give you on heating metal plus nitrogen dioxide plus oxygen, Ca. Potassium and sodium nitrate will give you nitrite and oxygen. Calcium to copper on heating will give you oxide, nitrogen dioxide and oxygen, like calcium oxide, nitrogen dioxide and oxygen. Mercuric nitrate and silver nitrate, because after copper we are having mercury, silver, gold, platinum. Gold and platinum, never it forms nitrates, we can say that, and if it forms, it is a waste for the gold and platinum, because that is being wasted, we can say that, because they are very costly metals, you know that. So in this way, silver, mercuric nitrate if you are heating it, or silver nitrate if you are heating it, you will be getting metal plus nitrogen dioxide and oxygen. And now last one, ammonium nitrate, NH4NO3, on heating we will be getting N2O plus water. N2O is nothing but nitrous oxide, which is called as laughing gas, we can say that. Alright, it's known as a laughing gas, this particular gas. Got it? Clear? It does not mean that on inhaling the gas you will be laughing. No, got it? You will be laughing it. So in this way, ammonium nitrate on heating will be giving you nitrous oxide and water. So remember this is for nitrates. So this is all about your chapter, that is nitric acid. Thank you very much.